Okay, so we're on section 13.2. We learned in the last section that electrons can be transferred from one reactant to another in oxidation reduction reactions. And electrochemical cells use a spontaneous redox reaction to generate electricity. So these are portable sources of electricity that are produced by spontaneous redox reactions. And electrochemical cells are also known as two other things. They're known as voltaic cells and galvanic cells. Okay, this is one of the most common applications of redox reactions. And the figure down on the left-hand side of the page gives you an image of like what something like this looks like. So can I move to the bottom of the page? Okay, so the basic design for an electrochemical cell looks something like this. So what we've got are two different compartments. They kind of look like two different beakers. And typically what you have is you're going to have a metal. And this piece of metal is known as an electrode. And in this case, the metal is magnesium. And on the other compartment, we have another metal. And this metal is copper. And based upon their location on the SRP table, which I'm going to give you a copy of, based upon the electrode's location on the table, that helps you predict which direction electrons will flow. So we're going to be looking at the purple side. That's those two dots. 3, 4, 5, 6, 7. Okay. So on the purple side of the laminated sheet that you just got, look on the left-hand side. There's a little tiny table. It's kind of small, a little bit hard to read, but this is the standard reduction potentials of half cells table. And if you locate magnesium and copper, and what you want to specifically look for is magnesium with the magnesium ion. Okay, so you're looking for that reaction. And then you're looking for the copper metal with a copper 2 ion half reaction. Okay, so tell me where one is. Like, which one is at the top and which one is at the bottom?
Magnesium's at the bottom. Copper's in the middle.
Copper's in the middle. So magnesium is at the bottom. And then the copper is in the middle of the table. Okay. So in this table, the electrons flow from the bottom to the top. Okay, so electron flow on the table is going from down here at the bottom to up at the top. So that's why, since magnesium is down here at the bottom and then your copper is up here at the top, that's why in this electrochemical cell, can you see how along this wire that's connecting the two electrodes, see how the electrons are moving from left to right, from magnesium to copper? Okay, so you would use this table to predict that, and you'll be doing this in your homework. Okay, and then the electrode or the half cell where the electrons are leaving, or where we're losing electrons, that would be the oxidation compartment or the oxidation half cell, right? Because this is where electrons are leaving. And wherever oxidation happens, we call that electrode the anode, okay? And then the electrons are going to the copper electrode, so that means we're gaining electrons, and this is where reduction is happening. And then wherever electrons are being gained and reduction occurs, we call that electrode the cathode. Okay? Now, as this happens, we have cations and anions in solution that help maintain the charge. And let me explain why that's needed. If you have electrons flowing from the left to the right compartment, aren't we going to build up a negative charge on the right-hand side? And that means you would end up having a positive charge build up on the left-hand side. So that means that the ions need to flow somehow from one compartment to the other to help maintain a charge balance so this doesn't stop working, okay? And on the next page, they talk about that. So on the next page at the bottom right, do you see where it says anions migrate towards the anode? Okay, so in this direction, to the left, because the anode is here, the anions will travel through the salt bridge to the left, and then since the cathode is on the right, the cations will travel to the compartment on the right. So the cations are going to balance out that negative charge from the electrons that are going to the right compartment. Does that make sense? Okay. Okay, now, I think that might be all that I have to mention for this container. All right, any questions on this? Okay, let's take a look at the next page. And on the next page, they talk about electrodes gaining mass and losing mass. So let me explain how this occurs. So the copper compartment on the right-hand side, the copper ions that are in the solution are taking electrons on, and they are being reduced, which means now we're forming copper metal. And that copper metal is going to accumulate on the copper electrode, and we call that plating. Okay, so wherever plating is occurring, that electrode will actually end up gaining in mass. And then here it says, in any cell where plating occurs, it will be at the cathode, and the cathode will increase in mass. And then for the other compartment, which is the anode is losing electrons. It will decrease in mass because we're converting those atoms into ions, and those ions will then just dissolve in the solution. So let's go back to the image on the previous page. Bless you. Okay, so on the previous page, if you take a look at the two electrodes here, what this would look like if we were to do this experiment is you would see little tiny pieces of solid metal start to accumulate on the electrode itself. So it's going to get heavier. So this will actually gain mass. And then you'll see this electrode start to decrease in mass. So it will start to get smaller. So parts of it will start to sort of like disappear. So like this part, these would just disappear, and then you would produce more of these magnesium ions in the solution. So this one loses mass. Okay? And then turn to the next page when you're ready. Okay, let's take a look at the quick check here. What I want you to do with the laminated table that I just gave you, I want you to locate the silver and silver ion reaction, and then I want you to also locate the chromium metal with the chromium 3 ion reaction, and I want you to answer these 4 questions. And let's see what you guys come up with. Okay, so based upon the locations that you found, where is the silver with the silver ion reaction? Is it at the top? Okay, so this reaction is at the top. And the chromium metal one is at the bottom of the table. And it's chromium with +3 ions, correct? Okay, so this is at the bottom of the table. And Amy, I'm just kind of like reviewing since you weren't here for this. So when you're looking at the table, whatever is at the top of the table, it accepts the electrons. So that means the electrons would have to move from the chromium to the silver. Okay, so through this wire, the electrons will travel in this direction. Okay, and then which electrode is the anode? How do you know that? What's the definition for an anode on the previous page? What does it say? Where oxidation occurs? Okay, so the anode is where oxidation occurs. Oxidation is loss of electrons, right? Okay, so this is clearly losing electrons, so that means that the silver must be the cathode, because the cathode would be where reduction occurs, and when reduction occurs, we are gaining electrons. Okay, so which electrode is the anode? You would say the chromium electrode, which is the chromium metal, because this right here is a piece of metal. Okay, and then in which direction do the electrons flow through the wire? Well, you could say they're flowing from right to left, or you could say that they're flowing from the chromium metal to the silver metal, which is just right to left. Okay. In which direction do the cations flow through the salt bridge? Okay, so cations flow towards what?
Cathode.
The cathode. So in the salt bridge, this is the salt bridge right here. In this direction, you will have the cations flowing. So they're flowing to the left to the cathode. And then which electrode gains in mass? Silver. So if this is gaining in mass, you'll see the little tiny pieces of metal accumulating. And if you tapped it, you could knock them off and it would sink to the bottom. So this is where mass is going to increase. This is called plating. So the silver electrode will gain in mass. Yes? Doable? Like you could do this on homework? This is what you're going to do on homework. Okay. All right, let's turn to the next page. Okay. Corrosion is an example of unwanted oxidation. So if we lived in California and we were along the coast, bicycle frames, other things like bridges, any metal is going to rust, especially iron. The corrosion of iron is rusting. And repairing this costs billions of dollars a year. So I would know that this is an undesirable, rusting is an undesirable redox reaction. Okay, we don't want this to happen, but it does. And then let's turn to the next page. And we prevent corrosion by a few things. We can paint the metal. We could grease it, or we could galvanize it. You've probably heard of galvanized metal before. So if you coat it with another metal and you sacrifice that metal instead of sacrificing the iron underneath it, that's a method for protecting it from rusting. And then I think that's it for section 13.2. Okay.